For this problem, we have apocryphal legend has it that Sir Isaac Newton discovered gravity when an apple fell from a tree and hit him on the head. If a 0.2 kilogram apple fell 7 meters before it hit Newton, how fast was it moving right before impact? Okay, so let's draw a little sketch. Let's start with ground level. I'm just going to use black. There you go. And then there's the tree. Okay. And here's the apple. So, because Newton was sitting somewhere, I don't know exactly the height, the distance from here to here, but I don't need it. Because if you think about it, it says that the apple fell 7 meters before it hit Newton. So then I'm going to assume that my zero line is, I'm going to say this is where Newton received the impact from the apple. So I'm going to say this is my zero line. That means the distance from here to here is 7 meters. Okay? And what I need to know is the velocity at this point. I need to know the velocity. That's the final velocity, okay? At that point. Okay, let's write down what we know. So we have the mass of the apple, which is 0.2 kilograms. And now, because we're going to apply conservation of energy, let's think what's the initial and the final height. The initial height is going to be over here before the apple fell. So we're going to say this is h final. And over here, at the impact location, we're going to have this is h initial and this is h final. So that means h initial, height initial is 7 meters. And then the final height after impact is, or right before impact, is 0 meters. Well, the initial velocity of the apple, it was just there. So the initial velocity is going to be 0 meters. And then the final velocity is what we're trying to find. We also know that the acceleration of gravity, which is why the apple fell, is 9.8 meters per second squared. So let's apply conservation of mechanical energy. Kinetic energy initial plus potential energy initial, I'm not going to have room, is equal to kinetic energy final plus gravitational potential energy final. Well, at first, the apple was not moving, so there's no initial kinetic energy. Then after impact, well, it reached the zero line, which means the final height is 0. That implies there's no final potential energy. So all the gravitational potential energy will become kinetic energy. So if we wanted to find the kinetic energy of the apple right before it hit Newton, we could just find the initial gravitational potential energy, and it would be the same amount because we're ignoring air resistance. Now let's substitute our equations. So we have let's change to black. mgh initial for gravitational potential energy initial, and then 1/2 mass times velocity final squared. Notice how the mass is going to cancel. Now we have gh initial is equal to 1/2 velocity final squared. So now we just solve for velocity multiplied times 2 to get rid of the fraction, take the square root. We have that the final velocity is the square root of 2g height initial. Let's plug in our numbers. We need more room. I'll do the square root at the end. So we have 2 times 9.8 meters per second squared times 7 meters. Let's use decimals. So we have the square root of 2 times 9.8 times 7. Let's round to 2 decimals, so 11.71. So the fake apple hit Newton at 11.71. I forgot already. 71 meters per second. And that's it. If I were to find the kinetic energy, now using this velocity, I would get the same amount. If I tried 1/2 mv squared with this velocity, I would get the same number as if I multiply the mass times g times the initial height. I would get the same energy. That's it.